Okay, guys, can you see me and hear me? Just let me know. Okay, we are about to begin with work, energy, and power. Okay, so we'll be talking in this session. We'll be talking about few, you can say, tips and tricks regarding work, energy, and power. Okay, so I hope everyone is doing fine. Okay, good afternoon, everyone. So how's everyone? Everyone having a good day? Sunday? Sundays are always a good day, right? So you must be having a good time, right? And this is here, Haris. You can say trying to teach you something. Yeah. So without any further delay, let's begin with the session. Okay. I hope you can say you learned something today from me. So starting with the first question that comes to, you can say that came in JEE Advanced 2014. And the question is like, consider an elliptically shaped rail PQ in the vertical plane with OP is equals to 3 meter and OQ is equals to 4 meter. A block of mass 1 kg is pulled along the rail from P to Q, okay, from P to Q with a force of 18 Newton, okay, which is always parallel to line PQ, see in the given figure, okay. So the question is something like this, that there is a object or mass and it is being acted upon by some force such that the force is always parallel to this line and it is helping, you can say, move the object from P to Q. We are interested in finding, you can say, the work done, okay, or you can say the final energy. So the background for this, or you can say the concept behind is work energy theorem. Let's talk about work energy theorem, okay. So what this work energy theorem teaches us is whatever work we do on something, okay, that results in the change in kinetic energy of that object. Let's say, for example, there is an object having mass m and velocity v. Let's say, for example, okay, and if we are working on that object, okay, we are doing work on that object, okay, this is for JEE Mains, Abhishek, okay. If we are doing some work on that object, what this work will do, okay, that question comes to my mind and it should come to your as well, okay. So what this work will do is increase in its kinetic energy, okay. That is, you can say a easier form of kinetic energy theorem or work energy theorem. So change in kinetic energy is equals to work done on the object. Okay, how many of you know this thing, well aware of this thing? And there is one more thing which I want to discuss is why are exactly we needing work energy theorem? So the answer to this is this work energy theorem makes our kinematics problems very easy. Okay, these questions can be solved using kinematics as well, but work energy theorem is way easier. Okay, so let's see if you guys can crack this one. In the meantime, I'll also do it. Okay, so what is happening here? Kinetic energy initial is 0, and we are interested in finding the kinetic energy final. Okay, so let's apply work energy theorem. So change in kinetic energy is equals to work done. Okay, now what are the forces that are doing the work on this object? In the present question is work done against gravity. Do you guys agree with this? Work done against gravity plus work done by 18 Newton. That will result in kinetic energy final minus kinetic energy initial. Okay, so do you guys following? Okay, so let's calculate work done against gravity. Okay, so work done against gravity will be minus mgh or mgh. Is there anyone who can help me with this? Why it is positive or negative? Is there anyone? Let's see if you guys are following it. Go ahead. Positive or negative? It will be positive or negative. So the logic behind is gravitational force is downward. Okay, gravitational force is downward, and the displacement is upward. That means work done against gravity will be negative. That is minus mgh. Okay, let's put the value of m 1, g 10, and height as 4. So what is the work done against gravity? That is coming out to be 40 joules. How many of you followed it and got it? Okay, good, good, good. Frame of reference, you can say no, but the direction of acceleration due to gravity beta are good. Okay. Now let's talk about work done by 18 Newton. Okay, that is force into displacement. Let's refer the figure now. Okay, so here what is happening? You can very clearly see that force is always directed, and it is mentioned in the question as well. Okay, so a block of mass which is always parallel to line PQ. So these guys are clearly mentioning that this force is always parallel to PQ. That means force and displacement are always parallel. That means F into D cos theta, theta will be 0 degrees. So work done will be F into S directly. Okay, now this in this triangle, this is 4 meter, this is 3 meters. So you guys are very well aware of these things, that this by using Pythagoras theorem can be calculated as 5 meter. If you guys are having a problem, let me do it. Okay, 3 square plus 4 square is equals to PQ square. Pythagoras theorem, simple. So it comes out to be PQ is, you can say, 5. Okay, so work done by 18 Newton will be 18 into 5, that is 90 joules. So let me know if you guys followed it. The topic is work energy theorem, Rani. Okay, 90 joules. How many of you followed it? Rianshi is writing 90 newtons, but the unit of work is joules, not newtons. Okay, so it is 90 joules. So net work done will be 90 minus 40, that is 50 joules. Work energy theorem is going on with Sunil. So you're asking me what's going on. So it's work energy theorem. Just try to catch up things. Okay. So let's now apply work energy theorem. Okay. So it says kinetic energy final minus kinetic energy initial is equals to net work done. Okay, now net work done, as we have already calculated, is 50 joules. Kinetic energy initial, as given in the question, is 0. So we know we don't need to write it. Okay, so I'll just eliminate it, and we are left with kinetic energy final, that is 50 joules. How many of you followed it? Just be honest and let me know if you guys are getting things. Okay, that's all that matters. Okay, you should get something if you are investing time here. Okay. Now they are asking. What they are giving the answer exactly. Kinetic energy in terms of n into 10 joules. So if we just compare n into 10. Good afternoon, everyone. Those of you who are joining late, you should not be late in, you can say, investing your time in towards studies. Okay, so n comes out to be 5. So how many of you understood it completely? Pallav is J clear. That's so great. Okay. What is UGH? There is no UGH over there, beta. It is MGH. I hope you guys are following it. Okay. Shall I move to the next one if you got it? Not me, Rajat, you're not following it. Okay, if you're not following it, you can always watch the recording later, because this session will be saved in our YouTube channel. Okay, so it's kind of, you can replay it again and again. Instead of you can say watching a movie, you can watch me. Okay, invest your time towards something which is beneficial for you. Let's move to the next one. Okay, understood. Let's move to the next one, and this is kind of a, you can say, very important question in terms of, like, it always comes. Okay, the same question is not going to come, but the concept will always be there. Okay, Okay, so let's see the concept behind it, okay, which is, you can say, motion of a particle in a circular motion. So here the concept lies is, the question is, okay, I'll just put it in a question. What should be the velocity at A such that it reaches C? Just reaches. Means it should not have, you can say, the question, if I just make it easy, so what should be the velocity here such that it just reaches C? Or you can say diametrically opposite point, okay? So for this one, we can use work energy theorem. Okay, we can use Newton's laws of motion, and the, you can say, concept that is lying here is tension at this point should be zero. Okay, and the derivations you can do it. So if we just you can say apply work energy theorem and Newton's laws of motion, basics of Newton's laws of motion, we'll get to know that the velocity at A should be 5 g/. Okay, root under 5 g/. How many of you are following it? Go ahead. Okay, so the velocity at A such that it reaches the point C, just reaches the point C, is it should be root under 5 g/. Now, the question that comes to my mind, and it should also come to your mind, is what will be the velocity at point C? What is going to be the velocity at point C? So the velocity at point C will be root gr, which can be very easily, you can say, derived if you just apply work energy theorem. Now, by this time, you guys must be feeling that, yeah, work energy theorem is really important. Okay, so it is just applying, you can say, conservation of energy. Okay, conservation of energy and work done by gravity. The velocity at point C is coming out to be root gr. Okay, so now the next question, the question number 2, which I am asking, and I'll also explain. So what should be the velocity at A such that it just reaches point B, and if we solve, it comes out to be root 2 gr. Okay, let's apply these basics. Okay, these were, you can say, the background of the question that is you can say coming next. Okay, this is the question which was asked in JEE 2008. So a bob of mass m is suspended by a massless string of length L. The horizontal velocity v at a position A is just sufficient to make it reach the point B. The angle theta at which the speed of the bob is half of that of A. So how many of you are feeling that, yeah, it's a tough question, and how many of you feel that you guys can do it? Okay, it's not a tough question, but yeah, it needs your concepts. Okay, so this question can be solved, you can say, using work energy theorem again. Okay, so you should feel the, you can say, importance of work energy theorem by this time. Okay, so what is the concept we are going to use here is velocity at bottom most point. Those of you who are finding it easy, you are very good. Okay, awesome that it is. So velocity at bottommost point, I just told you it is root 5 gr. The next thing is we'll apply kinematics. Okay, kinematics is always applicable for motion. Okay, so that is v square, or you can say 2as is equals to v square minus u square, initial velocity and final velocity. Okay, so no, don't tell the answer, don't reveal the answer of this question, Ambajay. Okay, well, your name is Ambajay, that's cool name. Okay, so in this question, the final velocity is given as half of the initial velocity, and initial velocity is given as root 5 gr. So let's put those values. Okay, it's a simple question. Okay, so final velocity is u square by, you can say, u by 2 then square. Okay, u by 2 whole square minus u square 2gh. Now, one thing, if you guys, okay, I'll just explain that thing as well. So just suppose there is a circle of radius, let's say L. So what is this height h? So h will come out to be L1 minus cos theta. Let's put those values. Okay, so it will be 2gl 1 minus cos theta is equals to, I'm putting the values of, you can say, u as well. So this is our u. Okay, so 5gr by 4 minus 5gr. Instead of R in the question, it is given as L, so we should use L only. So 5GL by 4 minus, you can say 5GL. So what? Now you can see that these are getting cancelled and we are left with cos theta is equals to minus 7 by 8. Okay, this step is like you can solve it. It's very simple maths. Now the next step is theta will be cos inverse minus 7 by 8, which is approximately 151 degrees. Okay, Hitel? Hitain, your name is Hitain, good. So now the question is asking what should be the range of theta. Okay, so if you guys very clearly see that 151 degrees, I should use another color. So 151 degree is coming in this range. Okay, in this range, and the answer to this question is D. Just let me know. You can apply conservation of energy beta. Yes. Okay. So let me know if you guys are following it. Okay. Without any further delay, let's move to the next one. Okay. And the next question, okay, so there is a, you can say announcement, or you can say a piece of information I want to share with everyone, that from now onwards, we are going to, you can say on from 12th of September, NEET live timings will be 3:45 to 4:15. So it is a good news for all the students who are preparing for NEET. Okay, and it is a PM. Obviously, it cannot be AM. Okay, so NEET live will be 3:45 to 4:15 PM for NEET students, because we are going only live for JEE. So we are taking care of that. And from 12th September, we'll be like live for NEET as well. And for JEE, the timings are getting changed. Initially, or you can say this timing is 3:45 to 4:45. Now it will be like 4:30 PM to 5 PM. So I hope you guys followed it. Okay, just note it down somewhere so that you can always be live, or you can see you can always attend those live sessions for your own benefit. Okay, so let's move to the next one. So why are you not teaching in our batch? Okay, so there comes a student which is asking, why are you not teaching? Okay. Okay, so I hope you guys are having a good time. I was just going through the, you can say, chat of yours. You guys are having a good time, right? See you in class. Okay, so the next question that comes is, okay, the next question, Hitain is asking me, Hitain, whatever you are saying is correct. Okay, just try, give an attempt once or twice. Okay, you can always get to an answer. Okay, the next question is really simple, and it is based on the concept. What is the concept behind the next question? If two equal masses. So guys, just let me know how many of you know this thing. It's a simple collision concept. And the concept of, if two equal masses collide, then velocities are interchanged. Okay, so suppose there is a mass m and another mass m. Okay, so u1 and u2, that is the velocities, these masses having velocities, different velocities. After collision, they just interchange their velocities. Okay, this is the concept we are going to use in the next question. So let's read it. Two small particles of equal masses start moving in opposite directions from a point A in horizontal circuit orbit, or you can say circular orbit. Okay, their tangential velocities are v and 2v respectively, as shown in the figure. Collision between the particles move with constant. Before collision, the particles move with constant speeds. After making how many elastic collisions, then that at A, these two particles will again reach the point A. So how many of you, means I feel, what I feel in this question is, it's really a general question. Okay, anyone can do it. It doesn't matter if you guys are, you can say, preparing for JEE or not. You can do this question if you think a bit. So how many of you are following the question, and how many of you are confident that you will be able to do it? Okay, so I'll just tell you. Okay, just keep watching. Maybe I did. Who is writing? Pathikrit, your name is very good. Okay, so what is happening, guys? Keep listening. So since this particle, let's call it A, and this particle as B. It is having a velocity v. So I'll just you can say mark the angles as well. It is 120 degrees, 120 degrees, and 120 degrees. Okay. So no, don't tell me, don't reveal the answer, Nitin, Shekhar. You are asking me to tell. So it's really good if you know the answer, but let's other also, you can say, learn something. Okay. So if the velocity here is v and the velocity here is 2v, so what is going to happen? This will, or you can say B will travel a distance of twice than that of A. So first collision will occur here. Okay, first collision. Okay, and what is happening after the collision? What will happen after the collision? That it will move back with a velocity v, because they are exchanging their velocities. Okay, and it will move with a velocity 2v. Guys, followed this thing. We are just applying the basic you can say concept of collisions. Okay, after this first collision, this will move with a velocity of 2v, and this will move with a velocity of v. Now they are on their you can say way back. So this is going in this direction and this is going in this direction. What is going to happen now? Now since this, you can say, particle A has acquired a velocity of 2v, so it will go something like this, and the next collision is going to happen here. A will be there, B will be there. Okay, and after the collision, there is no magnetic field beta. This is a question from collisions or work energy, and we are just practicing work energy. Okay, magnetic field will be discussed in later sessions. Okay, so just hold on and keep watching. Okay, okay. So now after the second collision, what is happening? So second collision is happening here. Okay, second collision is happening here. After this collision as well, these particles are going to exchange their velocities. So it will move with 2v and this will move with v. Okay. Now what is going to happen then? Then it will reverse back its direction, and the third collision is going to happen initially where the points started moving. So third collision will happen here. Okay, third collision. So the question says, after how many collisions they will reach again at point A? Okay, they're asking you after how many collisions they will reach at point A again. So the answer should be as clearly mentioned: first collision, second collision, and third collision. So how many collisions are there? 3 collisions. Okay, so after 3 collisions, they will exactly be at the same point where they started their journey, that is A. So the answer to this should be B. Okay, guys, followed it? Let me know. So as a conclusion, you can say what are the things that are important in this chapter is work energy theorem is really important. Pallav and everyone. Okay, work energy theorem is important in this one, and you should practice it well. If you want, you can say score good in your JEE. And for others, because we'll be live every day at the same time. Okay, so you can always subscribe to this channel. Okay, as per you can say need. Okay, so you can subscribe to this channel, and if you want to know more about JEE Bytes, so just go through this link. Okay, go through this link, you will get further information about it. Okay, so I hope you guys enjoyed it, learned something. Okay, Gaurav is asking me to repeat once. Gaurav, it is a YouTube session. The video will be there, so you can always replay it. Okay, make the most use of it. It's not always the songs that can be repeated. These videos can also be repeated, right, Gaurav? Okay, if you want to join classes, better just copy and paste this URL or type this URL in your new tab. You can say can input your details and join. Okay, so I hope this is enough for today. Let's meet in the next session. Okay, till that time, everyone, take care, good night, and have fun. Night, because yeah, this is the end of the day for most of us. Okay, so take care. We'll meet in the next class. Tab tak ke liye, everyone, take care, good night, have fun, and stay awesome. And you can always subscribe to this channel. Okay, good night, take care.